In this video, I am going to explain the experiment number 3, that is N and I by torsional pendulum. So let us look at aim of the experiment. So to determine the moment of inertia of a given circular disc and to determine the rigidity modulus of given wire. This is what the aim. Apparatus, we need circular disc, stand with the clamp, steel wire fixed between chuck nut, reference stick, thread, meter scale, stopwatch and screw gauge. Procedure: determination of moment of inertia of circular disc. The mass of circular disc, that is capital M, is found by weighing it in rough balance. The circumference C of circular disc is found using a thread and later measured by using meter scale, and calculate moment of inertia and tabulate that in tabular column. So this is what the procedure for moment of inertia. The circular plate is screwed along the diameter on the other chuck nut without permitting the wire to undergo any twisting while the body is fixed to it. A convenient reference mark on the circular disc is identified. The reference stick is placed just next to it. The body is given gentle rotation so that it oscillates in small amplitude with the wire as its axis. Without wobbling motion, at the moment when body reference mark crosses the reference stick, a stop clock is started. The oscillation is counted 1 when the body reference mark crosses the reference stick, again in same direction. Time taken, that is small t, for completing 20 oscillation is found under 2 trials, and the mean value of t is found, from which the period t and hence the value of t score is determined. And readings are tabulated in tabular column and the mean value of I by t score is found. The procedure is repeated for the circular disc along its axis perpendicular to plane of disc, and readings are tabulated in the tabular column. And the determination of rigidity modulus N of wire. The diameter of wire is found at 3 different points along its length by using a screw gauge, and tabulate the readings in tabular column, from which the value of R is evaluated. The length capital L of the wire exposed between chuck nuts is also found out. The rigidity modulus N is evaluated by using the formula N is equal to 8 pi L by R to the power of 4 into I by T square, so many Newton per meter square. And here is a tabular column for entering the readings. So one is, so here you can look at 2 axes, that is the wire perpendicular to the diameter and the wire that is parallel to the plane of the circular plate. And the corresponding moment of inertia is calculated using the formula mr square by 4 and then mr square by 2. And here columns are available for entering time for 20 oscillations, and then period of oscillations t will be calculated, and finally t square is also be calculated, and finally the value of I by t square will be recorded. For both the axes, the value of I by t square is recorded, and the mean value of I by t square is finally recorded at the bottom. And here is values, that is mass of the disc, that will be recorded in kg, circumference of the circular plate, that is recorded in meter finally, and hence the radius of the circular plate is given by circumference by 2 pi, and capital L is the length of the wire between the chuck nuts, and R is the radius of the wire, and finally I by t square mean value will also be calculated from the tabular column. And here you can look at the diagram, that is the rough diagram that we have to express in the record book. Finally the rigidity modulus of the given wire is expressed as N is equal to so many Newton per meter square. So in the end, I want to tell you about the demonstration video link that will be available in description.